Thank you for your interest. My name is Siva. I'm with Siva Corrosion Services. Today, I am going to talk about how to preserve our assets, particularly bridges. And how do we do that cost effectively is what we're going to talk about. So let's get started. But before we go into that aspect of things, I want to talk a little bit about how our structures deteriorate. And here's a graph that talks about the beginning when you first construct the structure to the time it's condemned at the end of its life. Typically, when you build the structure, it's in good condition, shown in the green right at the bottom of that graph. And as the structure ages, as it's exposed to salt and stress, internal damage occurs to the structure, and you still don't get to see it, but it's happening. And then finally, when you get to see it for the very first time, you're not panicking. You're not going to go and do an in-depth evaluation. Typically, we go fix the crack, remove the bad concrete, we patch them. That particular activity that we do, which is necessary, actually increases the corrosion and the rate of corrosion. And so this structure marches on towards, from good to fair to poor condition. And there comes a point where you have to make a decision whether you're going to keep the structure or whether you're going to condemn it and closely watch and build a new one. And so you want to typically, preservation, you want to do it well before you get to that critical point. So before we go any further, I want to talk a little bit about the components of effective preservation. Now, it has three different components to it: applying appropriate treatment and activities at the appropriate time, and that will extend the life at the lowest cost. That's really the essence of bridge preservation or asset preservation. And to do that, let's talk about what we need to achieve this. To find out what are the appropriate treatments and activities, you need the current condition of the structure. And at what time do I have to apply that appropriate activities? You need not only the current condition, you also need the rate of deterioration, what's going to happen in the near future, and you need the service life of the structure. And once you have that, you can identify various preservation options that is available for you, and then you calculate the cost of each one of those through the lifetime of the structure. Now you have the life cycle cost of various options. That is really what's the component of bridge preservation is. And let's go and find out. This was actually put out by Federal Highway. They formed an expert task group of about 25 people from around the country, working 2 years to put together a guide. It's called a Bridge Preservation Guide. Now, bridge preservation has certain aspects of it, as we just talked about. Preservation includes preventive maintenance and rehabilitation. It does not include replacement. So if you're thinking of replacing a bridge, that would not be considered preservation. Other than that, preventive maintenance is cyclical work that you can do. For example, washing the deck, lubricating the bearings, sealing the joints, those things that you can be doing before you even see a problem. Those are all cyclical, they're proactive, they are preventive maintenance type. Now, there are other things that you can do, like sealing the cracks and patching the deck and painting the steel structure that shows some corrosion. Those are condition based, but they're still preservation activities that you can do to extend the life of the structure. Now, there are some structures that would have gone further beyond the preventive maintenance that you can do. Those then come under what we call rehabilitation, where you are spending a little bit more money, but we're doing something that will address corrosion problem that is advanced, a little bit advanced. So those are the components, but you don't want to go to a place where your condition is so bad that you're trying to figure out whether to be replaced or whether we can pull along for another 5 years. That would not be part of the preservation activity. Now, with the preservation, you want to know, first we said we need to know the current condition. Now, in the past, we have used visual. NBIS is always, you go look at it, which is good. We need to do those things because we are looking for major issues or problems. However, visuals never tell us the actual condition that would help us to do preservation activities. It may help us to prevent failures. That's where we need to use a new technology that's available to us. It's called non-destructive tools that we have. And we also need to do electrochemical testing, meaning we need to find out where are the active corrosion locations within the structure and how fast are they corroding at those locations. Because in any structure, you don't see the entire structure corroding. Only a part of the structure or a section of the structure is corroding. So what we really want to do is to find out where those points are, how fast it's going, so you can apply a solution to those areas that would allow you to extend the life of the entire structure, allowing the structure to deteriorate uniformly overall. And then you can collect some samples as a part of this and test in the lab to figure out how much chloride you have. Do you have any problems with ASR, alkali silica reactivity? Do you have problems with sulfates? Do you have problems with pH of the grout within the post-tension tendons? A number of things we can do depending on what type of structure you're dealing with and what type of problems you're looking to avoid. So having said that, when you collect all the information, process it, you can then project what the remaining service life of this particular structure is if you don't do anything at all. And now, then we can say, well, if I don't do anything, that's my remaining service life, but I have an option. These are the various preservation options that I have that I could apply based on the condition of the structure and the property of the material. Now, once I have those options, I calculate the life cycle cost of this particular structure that you're dealing with, or a group of structure in a particular corridor, whatever it is. I want to go a little bit more into non-destructive evaluation and the tools we have. There are some tools that we've been using for quite a while, like ultrasonic thickness measurement for steel structures, or magnetic Mach particle testing that we're doing to identify where the cracks are within the steel structures. So we've used them for a long time. They're good tools, important, we could still continue to use them. But there are other tools that we are using now that are new that helps us, like for example, ground penetrating radar. It helps us to find where your tendons are, the high strength steel, where are your rebars, how deep are they, and how much of deck concrete or substructure concrete is contaminated and or corroding, so that you can identify generally where your problem areas are, so you can quickly go to those locations to collect samples or to do specific tests to further define how bad is bad. That's really what we're trying to do, so that we figure out where do we go from here, what options can I use to extend the service life by preserving, these structures. Here are some of the NDT tools that I just talked about. Here's the UT ultrasonic thickness to measure the thickness of the steel structures. Right below it is the ground penetrating radar that we use on highways and bridges. We can run at about 45 miles an hour to collect data and process it in our office to figure out the depth of reinforcement statistically. So we can say, hey, our chloride is only 1 inch deep, our steel is 2 inch deep, so we can easily remove the chloride tank sitting there and be able to put a new overlay and save the structure. Or your chloride is far deep even beyond the steel, so you have to use a different type of preservation treatment. So, and you have the Mach particle testing that identifies crack, and you have the infrared camera that identifies the difference in the temperature between one location and the other. How is that helpful? The locations where you have concrete damage is going to be warmer than the locations you have no damage. So you can quickly, by just pointing this camera, identify areas where you got problems. That's really, these tools help us to get to problem areas rather quickly than having to test the entire structure. So goal of preservation is to be able to do it quickly and at an early stage so that you can save the structure. Also, in addition to this tool, once you identify areas of problems, then you go to those areas, figure out what is the corrosion activity. Is it actively corroding? You can do the potential survey to find out. Now, once you find out it's actively corroding, then you measure the rate of corrosion to figure out how fast it's corroding. That is a very good piece of information. Remember, we talked about quantifying what has happened in the past and also quantifying what's going to happen in the near future, which then helps us to determine what are the options that I can use to preserve this particular structure, right? So once we identify the rate of corrosion of those locations where it's actively corroding, then you collect samples, the specific samples from those locations, and test those samples in the lab. The results of it will tell you whether there's confirming there's a corrosion going on, whether factors present to allow the corrosion to go on, will that keep on increasing? All that information we can collect from these laboratory results. And that's why you need to have a plan in terms of how you inspect your bridge. It's not just visually looking at them. If you really want to preserve the bridge, and the complex the bridge is, the more expensive the bridge is, you need to be planning and thinking and scheduling these type of inspections. Once you have the data, you can plug it into several software that are available, what's called Service Life Softwares, Life 365, Stadium, NCHRP 558. And what does it allow you to do is to determine how fast the concrete damage is going to occur and the time to criticality, meaning time to significant deterioration. When is it going to happen? That's really what it'll tell us. Once you have all that information, then you can say, hey, with the condition it's in, I can do this, this, and this, which is condition-based, or I can do non-condition-based. Like every year, I'm going to do the washing of the deck and the substructure to remove all the salt, to remove all the debris so that it doesn't collect salt and continue to corrode even after I stopped applying the de-icing salt. So that's a great way to preserve a structure. Or if you have a deck and it's leaking, you want to fix that so that you don't allow the salt to go in and corrode whatever underneath your deck. And or if you have a new deck, instead of just exposing it directly to de-icing salt, you seal the surface, which then allows you to slow down the salt from going into your concrete and start corroding the deck. So there are several things that you can do that are not condition-based, but are preventive activities that actually increases the time to deterioration, the first problems that you get to see. And there are some that you can do condition-based, like for example, if a deck is cracking or if a roadway is cracking, you don't want that to continue because in the winter the water is going to get in, freeze, and it's going to increase the problem. But if you take care of it as soon as you see it, then the water doesn't go in, it actually lasts longer. If you have a steel structure and you see spot corrosion, and it's easier to actually do a small area and take care of it, and it'll extend the life of it. So those are condition-based. You're looking at it, you see a problem, and you know I could have quick options that I could take care of. And there are other things that are rehabilitation that we talked about, because the corrosion has gone so far that you cannot use these washing or a sealing, because if you have so much salt in your deck, sealing the surface is not going to do anything because the salt is already there. It's going to corrode your structure. So there are other options that are available to be able to extend this life and prevent any further corrosion. Those are called cathodic protection. If the salt is not up to the steel level, you can remove it and put an overlay on it. So overlays are a very good way of rehabbing a deck, but on the substructure or the marine environment, the salt is always there. So only way you can really extend the service life and preserve your structure is by using what's called cathodic protection. What it is it puts out a small amount of current to counteract the corrosion current so that you are preserving your structure. And that is an example that Florida is doing a lot of their structure because a lot of them are in seawater. And here's an example of where you can pull out the salt that's already gotten into your structure was using a technique called electrochemical chloride extraction, where you're actually positively charging a metal and your negatively charged chloride ion is pulled towards the possibly charged metal. So that's what you're doing in this particular structure here. It may take 90 days and that's it. When you're finished, you seal the surface and you move on. That's a very good way to rehab a structure by not only pulling out the chloride, but also repassivating the steel. And there are other preservation activities for steel structures where you can use inorganic zinc sprayed thermally to protect your steel structures. And there are complex bridges. I mean, things like fatigue-prone steel bridges, or post-tension box cutters where high-strength steel is in the web walls, or stay cable bridges where you have huge cables that's holding the deck, and or pre-stressed beams that span 100, 150 feet, or continuous pre-stress spans, where these are complex bridges. They cost a lot of money. They're difficult to even evaluate and find out what's going on inside. But that was in the past. Today, we have NDT tools that we can use to get us closer to what's going on inside. What is the condition? We can get closer, and our decisions can be data-driven. It doesn't have to be simply, I don't see it. We can do that. Why do we need to do preservation? We want to keep the good bridges in good condition. And how are we going to benefit from it? Well, it improves the overall condition of our assets. It gives us longer life for our structures and reduces the overall dollar we spend through the lifetime of the structure. Now, why is that important? It gives you equity in your structure, like you build equity in your house, that then allows you over time to be able to use that equity to invest in other things. If we maintain our infrastructure, then we have enough money to be able to build other things so we could be competitive in the world. And that's the reason we want to embark on preservation. So if you have any questions, I'd be happy to take them. And thanks for your attention. Again, my name is Siva, and you can reach me at siva@sivacorrosion.com or at 610-692-6551. Thanks.